Last class we learned about the quadratic formula. We learned how it was developed in terms of taking a standard form equation and changing it to its vertex form. And then we rearranged the vertex form to isolate for the x and came up with that thing called the quadratic formula. Today for warm-up, what I'd like you to do is solve each of these three equations by using the quadratic formula. Put the video on pause, try it out, turn your iPad or iPhone or phone upside down, and then you can check after you've finished to see if your answers match mine. All right, if you have solved your quadratic equations, you should have gotten the final answers as I have below. I had, for the first one, x is approximately equal to 0.43, and then x is approximately equal to negative 3.10, when you round that correctly. The second one, I got two answers, but they're actually the same answer, so there's really only one x-intercept here. It's x equals 1. And for the last one, you end up with a square root of negative 44, which if you punch that into your calculator, you get an error on that. And that's because there's no number in the real number system that when you multiply it by itself, you end up with a negative answer. Because a positive number times a positive gives you a positive number, and a negative times a negative also gives you a positive. So I put in yellow here, no solution, since we can't square root a negative number. Well, I want to look at what each one of these functions, the related quadratic function, would look like if we were to graph it. So my first related quadratic function for part A above would be if I type in y equals a 3x squared plus 8x minus 4. I know this is a parabola because it's degree 2. I know my parabola opens up because I have a lead coefficient of 3. I know this parabola has a y-intercept at negative 4, and I know my two x-intercepts, which are up here. So I could sketch that out. You can always put that in Desmos as well to check it out and make sure you've got everything correct. I want you to do the same with the other two equations. So for part B, you should have y equals 2x squared minus 4x plus 2 as your equation that you put in. You know it's opening up, you know the y-intercept is at 2, and there's one x-intercept at 1. The last one for part C, punch this one into Desmos, 3x squared minus 4x plus 5. Should be opening up also a y-intercept at 5, and that's all we know about that one. And then in this space, I want you to sketch what that looked like when you graphed it. And we'll check it out on the next slide. Which are here, good. Okay, and I want you to take a look at what we have on the line before we break it down into the two parts. So the three lines before we break it down into the two parts. In the first one, in the blue example that I have here, I want you to look at what we have and see if you can figure out where a negative 4/3 could come from. And if you've got that, you think you've got it figured out, take a look at the next one and see if that's true for the next one. Where would the number 1 come from? From the line here, before we actually split it into two parts. And likewise, the last one was 2/3, the red one. So look at this line, the last line here, and see if you can figure out where 2/3 comes from. Talk it over with your neighbor. See if you can get it worked out. And then I'm going to put a summary on the next slide with question 3. Okay, hopefully you and your neighbor have figured it out. What I'm noticing is in the front we have a negative 8 divided by 6, which would reduce to negative 4/3. In part B, I have a 4/4, which in lowest terms equals 1. And in part C, we have a 4/6, which would be positive 2/3. So it looks like we can predict the x-coordinate of the vertex by looking at the front part of our quadratic formula, which is also the part that says we have negative b, and then divided by what's on the bottom, which is a 2a. So our x-coordinate of our vertex will equal negative b over 2a. So if we go back to our quadratic formula, the fact that we get a 112 here. We're going to add that value and subtract that value. As long as that has a positive number under the square root sign, we're going to get two different values, one where we're adding that value and one where we're subtracting that value. If we end up with a 0 under the square root sign, so this was the square root of 0, then we have nothing to add or subtract to that 4 over 4, for example. So that ends up in one solution. So anytime that thing under the square root sign ends up equaling 0, there will only be one solution to it. The last one here had a negative under the square root sign. So when you get a negative, there will be no solution or no x-intercepts because you can't square root the negative under the real number system. So to summarize that, if you've sketched your functions with the help of Desmos, you should have easily gotten the coordinates of the vertex along with the other points that we knew, which were the zeros and the y-intercept. Now, for question 3, it says determine the relationship between the x-coordinate of the vertex and the values in the quadratic formula. So what we're going to do here is take the values that we got for our x-coordinates of our vertex, so -4/3, the 1, and the 2/3, and we're going to look back at our actual quadratic formula solutions that I have on the slide before. That on this next slide here. So our summary here is that the x-coordinate of the vertex is equal to -b divided by 2a, where the b is the coefficient of the x term and the a is the coefficient of the x squared term. Question 4 says, what part of the quadratic formula determines, that should be determines, if there will be one solution, two solutions, or no solutions? Now you'll notice part A had two solutions, so we have 2 zeros for that graph. Part B had one solution, or two that were exactly the same. You'll notice in part B we have one x-intercept, and for part C we had no solution, and you'll see that part C, the parabola, never crosses the x-axis and has no x-intercepts. The part that actually determines whether there would be one solution or two solutions lies back in part of the quadratic formula. The part of the quadratic formula that will determine if there is one solution, two solutions, or no solutions is the part that's under the square root sign, the b squared minus 4ac. And if it is greater than 0, so if that b squared minus 4ac is greater than 0, there will be two solutions. Okay, or if you want to put the word positive there instead of the greater than sign, that might help you remember it better. It's up to you. If that part under the square root sign, b squared minus 4ac, if it's equal to 0, there's exactly one solution, or one x-intercept if we're looking at the parabola. And if that b squared minus 4ac ends up being negative, 4ac is negative or less than 0, this is the case where there's no solution. Okay, now that part under the square root sign, that b squared minus 4ac, that is known as the discriminant. Okay, so b squared minus 4ac, that is called the discriminant because it discriminates between whether there's going to be two solutions, one solution, or no solutions. Discriminant. There we are. Discriminant. And that was the title for our note today.